In this video we're going to be looking at differentiating the natural logarithm and similar functions. So we should hopefully know that the function ln of x is the inverse of e to the x, so there is the graph of it, and of course it only exists for positive values. To think about the reason for that, try and think about what you know about the domain and range of a function and what happens to those numbers when you find the inverse function. You should also know that the exponential function can only ever be positive. Therefore, when you do the inverse, it only works for those positive values. Now, the differential of the natural logarithm function is still quite nice, but not as nice as e. If you differentiate ln of x, you get 1 over x. And what we're going to do is we're going to use, like we did with when we differentiated e, we're going to use chain rule and see if we can make a more general formula for what happens when you differentiate ln of a function of x. So the first one, we don't actually need to use chain rule for. First couple actually. Dy dx is just going to be 3 lots of 1 over x, which we could even write as 3 over x. For the second one, same idea, that 1/3 is still just a constant, so it's just going to be 1/3 of 1 over x, which we could write as 1 over 3x. And c is the first one where we're now going to have to start looking at using the chain rule. So we're going to let u equal 3x plus 1. That means du dx is just going to equal 3. This also means though that y is now equal to ln of u, so dy du is going to equal 1 over u. And what we're now going to do is we're going to multiply these two fractions together, and that's going to work out dy by dx. That's going to get us 3 lots of 1 over u, which equals 3 over u, and if we substitute u back in, we get 3 over 3x plus 1. And hopefully this next one is where you'll really see how we're going to establish our shortcut. We're going to let u equal x cubed plus 5x squared minus 7x plus 1. So du dx equals 3x squared plus 10x minus 7. Meanwhile, y is now equal to a much simpler function. It's ln of u, and dy du equals 1 over u. Now we're going to multiply these two blue bits together and see what happens. So we get dy dx equals 3x squared plus 10x minus 7. We're going to times that by 1 over u, so it's that function all over u, which equals 3x squared plus 10x minus 7 all over x cubed plus 5x squared minus 7x plus 1. And hopefully from that last answer we can actually see what our shortcut's going to be. What we've got in this final answer here is that bracket, the original bracket, is now our denominator, and our numerator is the differential of the denominator. If we differentiate this bottom line, we get the top part of the fraction. And if we go back one question, we can spot that it actually works for that one as well. That 3x plus 1 we placed at the bottom, and if we differentiate 3x plus 1, we get 3, which was at the top. So to make a more general function here, we're going to say if y equals ln of a function, then the differential is going to be f of x at the bottom and f dash x at the top. Now this actually comes back quite a lot later on when we start looking at integrating certain fractions. If we can spot that the numerator is the denominator differentiated, then we know that when we integrate we could use the ln function to help us out. So now that we know that little shortcut, we're going to try and do in some of these. Either it says here with chain rule perhaps, or maybe just law of logs. So y equals ln of x cubed. Well, we know we could write that if we really wanted to as 3 ln of x, and if we differentiate that, then dy dx is just going to be 3 over x. We had that one earlier. If we wanted to use our new idea, we could get the same answer, because x cubed would go at the bottom and on the top would be that thing differentiated, so that's going to be 3x squared, and we can hopefully see that that x squared is going to cancel out with 2 of those x's, and that will leave us with a 3 at the top and an x at the bottom, and it gets us the exact same answer. Now for part B, we'll do the shortcut idea, and then I might change the question and show you what happens here. So if we want to differentiate ln of 3x, we know the 3x is going to go at the bottom, which means there'll be a 3 at the top, and those 3's would cancel out, and we're left with 1 over x. Now this answer actually occurs any time we have an ln of something x. So if that wasn't a 3, if this number here was like a 10, we'd get a 10x at the bottom and a 10 at the top, and the 10's would cancel out, and we still get left with 1 over x. So any time we're actually differentiating y equals ln of a multiple of x, we're always going to get 1 over x. And then for the last one, again we could do this a few different ways. We could write this first of all, if we wanted to, as ln of x to the minus 3, and bring that minus 3 down to the front and go from there. Or we could keep it and write it as the denominator is going to be x to the minus 3, and if we differentiate that, we're going to get a minus 3 x to the minus 2, and then similar to what we had earlier on, some of these x's are going to cancel out, and we're still going to get left with minus 3 ln x. I've done that last one wrong, I apologise. Let me just rewrite that. I was looking at it thinking that looks weird. I cancelled that out wrong. It's going to be minus 3 over x. That looks much better. Right, so can we now try and apply that idea to some straightforward questions? This one says, find the equation of the normal, let me just highlight that word, to the curve y equals ln of x, 3 plus x squared at the point where x equals minus 1. Okay, so let's have a think how we could do this. Let's start off by maybe even writing it as y equals ln of, well, I was going to multiply it out, but I might just keep it as it is. It might be just as easy to keep it like that. That means when we do dy by dx, we can keep the 3 plus x squared at the bottom, that's the function. And then if we differentiate that, we can put that on the top. So if we differentiate that, that means we're just going to get 2 lots of 3 plus x, which means what we're really going to get is a 2 over 3 plus x. And we could have actually done that in a few different ways. Like I said, I could have multiplied it out. I could have written this as 2 ln of 3 plus x, and if I did that, that means I'd get 1 over 3 plus x times by 2, which gets us the same answer as well. Right, so we need to work out the equation of the normal. So we need some numbers first of all. So when x is minus 1, if we plug that in and work out the y value, we're going to get y equals ln of, so if we put in minus 1, we're going to get 3 plus minus 1, which is 2. 2 squared is 4. And we're going to get this m value of, so if we plug in minus 1 into here, we're going to get 2 over 2, which is 1. Now this m value here, I'm going to make a little note that this would be the tangent gradient. Therefore the m value that we want, so we call that m1, this can be m2, is going to be minus 1. That's the one we need to use. That's going to be the normal gradient. So now we're going to plug it into y equals mx plus c, and we get ln of 4 equals minus 1 times by minus 1 plus something. So minus 1 times minus 1 is positive 1. That means c is going to equal ln of 4 minus 1. And therefore, the actual answer to the question, the equation to the normal, is going to equal y equals minus x plus ln 4 minus 1. And for our final example, we now need to show that the curve y equals 24 ln x minus x cubed has a stationary point when x is 2, and then work out if that point is a maximum or minimum. So let's start off by doing dy dx and going from there. So if we differentiate 24 ln x, we get 24 over x. If we differentiate negative x cubed, we're going to get negative 3x squared. We should write down that it's a stationary point. That means it will occur when dy dx equals 0. So we want 24 over x minus 3x squared to equal 0. 24 over x equals 3x squared. That means 24 is going to equal 3x cubed. So 8 equals x cubed. 2 equals x. Okay. That's the first part done. We have shown that there's a stationary point when x equals 2. Let's maybe even write that out. Therefore, stationary point when x equals 2. So now we need to determine its nature. That means we now have to work out our second derivative. So d2y by dx2 equals. So we now need to differentiate 24 over x, which is 24 times by x to the minus 1. So it's going to be minus 24 x to the minus 2 minus 6x. Or if you want, I could write this as minus 24 over x squared minus 6x. When x equals 2, the second derivative becomes minus 24 over 2 squared minus 6 lots of 2. So 2 squared is 4, minus 24 divided by 4 is minus 6, minus another 12 means we get negative 18. Negative 18 is less than 0. Therefore, the stationary point is a maximum. and that is how we differentiate ln of x and how we can use it to solve any type of calculus questions involving the differentiation of it.